I've always admired your persistence.
I prefer to think of it as perseverance.
I'll bet you do.
You must have heard the great news by now concerning NASA's Perseverance, which launched on July 30, 2020 from Cape Canaveral's Air Force Station, Florida, and landed on Mars successfully yesterday, February 18, 2021, at the site of an ancient river delta in a lake that once filled Jezero Crater. It should go without saying that this is an impressive landing, and watching the live stream yesterday was very thrilling. So we're going to talk about this major achievement today and why this maneuver is incredible and slightly unnecessary. Hi, I'm Omz and welcome to OmzLaw. So, according to NASA, the rover is designed to better understand the geology of Mars and seek signs of ancient life. The mission will collect and store a set of rock and soil samples that could be returned to Earth in the future. It will also test new technologies to benefit future robotic and human exploration of Mars. It'll spend at least 1 Mars year, that's 2 Earth years since it takes Mars 2 Earth orbits to complete a single orbit, exploring the landing site region. Entry, descent, and landing is the shortest and most intense phase of the mission. It begins when the spacecraft reaches the top of the Martian atmosphere, traveling nearly 20,000 kilometers per hour, and ends about 7 minutes later. I must stress how difficult this task is, as only about 40% of the missions ever sent to Mars by any space agency have been successful. This is due to a long list of issues, and we have gotten better at getting there, but the major problem is basically the gravity of the Earth and NASA's ever-dwindling budget, but it's also due to the time delay, which forces Perseverance to handle everything by itself. During the landing, it takes more than 11 minutes to get a radio signal back from Mars, so by the time the mission team hears that the spacecraft has entered the atmosphere, in reality, the rover is already on the ground. So, Perseverance is designed to complete the entire process by itself, autonomously. 10 minutes before entering the atmosphere, the spacecraft shed its cruise stage, which houses solar panels, radios, and fuel tanks used during its flight from Earth. Only the protective aeroshell with the rover and descent stage inside made the trip to the surface. Before entering the atmosphere, the vehicle fired its small thrusters to reorient itself and make sure the heat shield was facing forward as it approached the planet. The drag caused by hitting the thin atmosphere slowed it down, but these forces caused a lot of heating as well, so the heat shield had to survive almost 1,300 degrees Celsius. That's higher than the temperature of the Earth's core, by the way. Inside, however, the rover sat comfortably at room temperature. As it began its descent, the spacecraft encountered pockets of air, which nudged it off course, and so it fired its small thrusters on its back shell and adjusted its angle at the direction of lift, helping it stay on the path to its downrange target and prepare it for parachute deployment. Now under 1,600 kilometers per hour, it was safe to deploy the supersonic parachute. To get the timing just right, Perseverance used a new technology called a range trigger to calculate its distance to the landing target and open the parachute at the ideal time to hit the mark. The parachute, almost 22 meters in diameter, deployed at an altitude of about 11 kilometers, and 20 seconds after that, the heat shield separated and dropped away. The rover became exposed to the atmosphere of Mars for the first time, and the cameras and instruments began to lock onto the fast-approaching surface below. Its landing radar bounced signals off the surface to figure out its altitude. Meanwhile, another new technology, the terrain relative navigation, kicked in. Using a special camera to quickly identify features on the surface, the rover compared these to an onboard map to determine exactly where it's heading, as NASA had already mapped out the safest areas of the landing zone in advance. In the thin Martian atmosphere, the parachute was only able to slow the vehicle to about 320 kilometers per hour, so Perseverance cut itself free of the parachute and descended the rest of the 2,100 meters using rockets. It reached a final descent speed of 2.7 kilometers per hour and initiated the sky crane maneuver. With about 12 seconds before touchdown and now 20 meters above the surface, the descent stage lowered the rover on a set of cables about 6.5 meters long. Meanwhile, the rover unstowed its mobility system, locking its legs and wheels into landing position. As soon as the rover sensed that its wheels touched the ground, it quickly cut the cables connecting it to the descent stage. The descent stage flew away to make its own uncontrolled landing on the surface, a safe distance away from Perseverance. So, why is this all necessary? Couldn't NASA have come up with a better technique? Well, this method was used on Curiosity, and I've left a link here discussing that maneuver as well, but essentially NASA needs to do this since it faces a load of issues back here on Earth. First off being the gravity problem, which I will discuss in a future video regarding the problems with SpaceX's Starship, so if you don't want to miss that, make sure to subscribe and hit that notification button. In order to change this maneuver, we need to have a serious talk about NASA's budget. Perseverance had to leave the Earth at a speed of 39,000 kilometers per hour, and this is a basically one-time gamble. They have to fire the engine once and then use the thrusters to make course corrections or minor speed adjustments. This is a risky technique to say the least. Not only does Perseverance not have enough fuel to insert itself in orbit, it also does not have enough fuel to perform a slow landing in order to minimize the risks involved, like we see in the moon landings. If we're gonna go to Mars every time by firing a bullet at it and hoping it hits the mark, we are bound to crash a few probes. Again, the issues here are highlighted in a previous video if you want to check them out, but in summary, the more cargo you want to put on Mars, the less propellant you'll be able to get there. And so NASA has to rely on all of these methods to slow down the vehicle and not go over budget. So this is the crux of the problem, honestly. NASA's 2021 budget is about $23.3 billion. Although this is a 3% increase over the previous year, it's a joke to be honest. Perseverance costs $2.7 billion by itself. And to those who think it's way too much money to spend on a space program, you're wrong. And I invite you to research how an MRI was invented, you know, that machine that saves your life every once in a while. Let's look at the US's military budget, for example, which measures in at about $934 billion. This is absolutely ridiculous. We don't need to spend that much money, or any money for that matter, on killing people or imposing our imperialistic military might. NASA's budget is less than 2.5% of that. I'm not suggesting we defund the US military, although as a believer in peace for all mankind we really should. But how about we just give 80 or 40, heck, just another 20 billion to NASA, just double its budget already. I'm sure then the engineers will be able to explore more solutions to this that are slightly more expensive yet pose less risks on the whole mission. They could work on having propellant reserves or orbital refueling. Orbital insertion must be one of the ways we explore in entering Mars. That way, we can also bring down the percentage of lost vehicles. Of course, not everything is made by NASA, that's why all of its missions are expensive, and this whole stagnation in the industry due to the monopolization of space by certain people has led to the rise of all of these independent companies, agencies, or entities that are leading the way in getting us there to the red planet safely. SpaceX should therefore avoid this technique as well with its suicide dive maneuver, and we are going to explore in another video how SpaceX will eventually do that. And that's all I have for today. Let me know what you guys think in the comments and what future methods NASA can explore in order to minimize the risks presented by the 7 minutes of terror. Don't forget to like this video if you enjoyed it, and I'll see you next time with more content about space. And as always, thank you for watching.